is that it will momentarily cut off blood supply to the brain so that the person will lose consciousness and become horizontal. They'll fall down. And by being flat, the body, it's much easier for the body to manage blood pressure and equal blood flow to all necessary parts than it is for a person when they're standing up. For those who are into engineering, the pressure differences, the pumping requirements for water to be lifted up to a tower tank are vastly different for every foot that tank is raised above the ground. So in order to make it the easiest for blood to flow to the head, there is a protective mechanism that causes someone to faint, so that the head will lower down and come to ground level rather than be up at head level 5 or 6 feet above the ground. Okay, so as in the movie The Shining, sensory apparatus took in a massive blood loss. People's protective mechanisms caused them to enter into shock, or a mild form of shock, in order to protect them from that massive blood loss. Well, so forgetting the fiction element at the moment, when a person experiences a massive fluid loss, the body will begin the shock mechanism in order to preserve fluid, to preserve critical circulation to the brain. That's ultimately what shock is. The odd thing is, here it is a very deadly process. It's actually a protective mechanism. Shock is the process of the body attempting to conserve volume in the presence of a volume loss, so that it can preserve necessary circulation to the brain, so that the brain can continue to get the oxygen and glucose that it requires to stay alive. Okay, so the thing is, this process can get out of control, and along the road of it being out of control, it can result in death. Let's look at how that happens. It's actually a sort of interesting feedback thing. Let's say a person experiences a serious wound and they lose a significant amount of blood. The control room manager goes into emergency preservation mode and hits the shock button. We'll think of it as that. In order to conserve blood to the critical vital organs, that being the central core organs and especially the brain, to control room manager's supply line itself, it will close down circulation to unnecessary or non-vital parts of the body. First of all, it will cause fainting, so that we get horizontal, so that it's a lot easier for it to maintain blood pressure to the brain. Okay, so the person will fall down and be lying on the ground or lying on a flat surface. Okay, next it will cut off the piping going to unnecessary body systems. This includes the hands and feet, since the person is not conscious. This generally will include the thinking parts of the brain, because as compared to survival, to control room manager is going to maintain its own supply line, and whether or not someone can think clearly to control room manager is not important. Going to cut off circulation to hands and feet, reduce the blood flow to those muscles. It's going to stop blood flow and process. Remember, I said it controls all the chemical processes going on. It's going to reduce blood flow and stop the chemical processes of the stomach, digestion. It's going to stop the gut, the intestines, and processing of waste, the kidneys. It's going to continue blood flow to the heart and to the lungs and everything else, pretty much. The heart, the lungs, and the brain. Basically everything else to control room manager is extra and unnecessary during an immediate shock reaction survival mode. Okay, so all this blood flow gets, if not cut off, then vastly reduced. This goes on for a few minutes. The blood loss is reduced, but let's say there's continuing blood loss. Volume still goes down a little bit. But what happens over time, 30, 40, 50 minutes into the process, is all of these parts of the body that have reduced blood flow start to complain, because tissues there are going to start to get damaged. So all these things start to put in complaints to the control room saying, hey, I need blood flow, I need oxygen, I need glucose too, you've got to give me some supply here. And enough complaints come in that control room manager says, okay, all right, okay, and opens up those blood vessels again to feed those body parts. Well, by doing that, it had built up. It's remember, it's kind of like there's a meter at the control room manager's area of pressure that it needs. And when the initial loss occurred, that pressure dropped dramatically so that it set off alarms and started the emergency shock reaction. Then, through the process of the shock reaction, the pressure had built back up so that it was at an acceptable level. Then the complaints came in, so control room manager says, okay, I'll open up circulation again. So it opens up circulation and blood supply to other parts of the body, and that pressure in its own area drops precipitately again because the volume is not there to provide normal blood flow. So again, the pressure indicator drops to a point that control room manager considers dangerous to its own survival. So again, 5-10 minutes after it had opened up circulation, it shuts it down again because it needs its own chamber's pressure brought back up. So now there's been more blood loss because circulation was opened to those parts of the body, including the part that is bleeding out. But we have less volume, and again the pressure is dangerously low for control room manager. So again, it shuts off all those unnecessary ancillary systems in its judgment, and it starts to build up pressure to its own area again. However, this time the pressure is not as high as it was because there's not as much blood as there was. But because all those other parts of the body only got fed for a few minutes, they are much quicker to start sending complaints to control room manager. If the pressure has come up to the point where control room manager is feeling again kind of safe and like it's not dangerous to itself, it gets all those complaints. So it opens up those blood vessels again and allows blood supply to all the parts of the body, and the pressure precipitately drops again. And then even quicker, it shuts that blood supply off and begins to build up pressure, but again, there's been more blood loss. So you can see what happens. Every cycle of this opening closing, there is less volume to the system. Ultimately, when there is not enough circulation to the control room to provide the oxygen and glucose that are needed, control room manager itself loses control, relinquishes control, and can no longer manage blood vessels, heartbeat, and breathing, causing death. This is the nature of Allen's statement that ultimately shock is the cause of death of us all. That ultimately it's the body's inability, the brain's inability to manage sufficient pressure and circulation to all the vital organs, particularly the control center of the brain. So what do we do about shock? Well, in an accident situation, the ultimate cure or the ultimate solution for shock is to provide volume. That's why the only people that can really treat shock effectively and take care of it and reverse it are medical personnel who can provide IV fluids. That's why one of the first things that happens in a shock situation is provision of IV fluids by the ambulance personnel, because they are providing volume back to stop the shock cycle. They need to bolster the blood pressure. Okay, but what can we do to reduce it? Well, we can help someone be comfortable in a lying down position. We can elevate their feet 10 to 12 inches if there's no leg, hip, back injury, so that it helps gravity bring blood to the body core and vital organs, which makes it a little bit easier for the control room manager to stabilize blood flow. We can keep someone warm so that we don't put demand on their thermal system, so that they